Good afternoon, everyone. I'm delighted to welcome you to our webinar on Welcoming All, Universal Design for Doorways. My name is Genon Wang, and I am the Assistant Education Director for the RAI. The RAI and its Universal Design Task Force are delighted to partner with the Centre for Excellence in Universal Design to promote today's webinar. This is the last in a series of 4 webinars on different aspects of universal design in the built environment. We hope that you have enjoyed and learned from the 4 webinars and will be taking those learnings back to your own practice. Following today's final webinar, the Centre will send out a survey looking for your feedback to improve future events. We're also asking you for your preference in relation to future CPD content. So I would encourage you to respond to the survey. Before we start, I'd like to highlight some accessibility features with you. Live captions are being provided by PCR. You can turn these captions on and off using the CC button at the bottom of your screen. And we're also joined by Irish Sign Language interpreters Catherine White and Nair Murray. To control the ISL interpretation feature, you can use the icon that looks like a globe. This will appear shortly at the bottom of your screen. On some screens, it might be under the More button. So today's webinar is being recorded, and it will be available over the coming weeks on the Centre's website at universaldesign.ie. The Centre will also provide CPD certs to anyone who requested one at registration. I'm sure you're all interested in receiving a cert as we approach our yearly CPD deadline. And now I'm thrilled to introduce today's speaker. Eoin O'Herlihy is a chartered engineer, an independent accessibility and universal design consultant, and managing director of O'Herlihy Access Consultancy. Eoin has over 18 years international experience with universal design and is an IAAP Level 3 certified accessibility professional in the built environment. He's passionate about accessibility and making all aspects of society fully accessible for everyone. Eoin recognizes the barriers faced by people with disabilities and aims to support organizations to remove these barriers and create a more inclusive society. Eoin will speak for about 40 minutes, and we should have 10 to 15 minutes for questions at the end of his presentation. And please use the Q&A function on Zoom to send in your questions, and we will get to as many of those as we can. So on that note, without further ado, I'm pleased to hand over to you, Eoin.
Thanks very much for that lovely introduction. I'm just going to share my screen if that's okay. Good afternoon, everyone. And as Gwynlong has mentioned, my presentation today is called Welcoming All, a Universal Design for Doorways. And I'm delighted to be here this afternoon to give you an overview of some of the accessibility and universal design issues that we have come face to face with on projects that we've been working with over the number of years, whether it's during design or during construction stages that impact on door design, but also circulation around buildings. So, as you're all aware, the seminar is being hosted by the Centre for Excellence in Universal Design in conjunction with the RAI. So, in relation to the presentation today, some of the learning outcomes for the session include improved awareness of the diversity of users impacted by door design, enhancing your knowledge of the features that can improve the accessibility and usability of doors for a wide range of users. And I suppose the main area we look at is an awareness of the common accessibility issues that arise with door design in building projects throughout design and construction. So as part of that process, what we've done is we've identified 11 kind of key areas where there can be issues in relation to the design of doors, but also during construction, where things can go wrong during the latter stages of construction or at early stages of design and so on. So I suppose it's important to start by, you can see some of the issues. We're going to talk about vision panels, ironmongery. We're going to look at door thresholds. We're going to look at the difference between access and egress doors. but also the importance of manual and operated doors and so on. So it's important, I suppose, to recognise at the start of the session that we want to look at, I suppose, regulations versus good practice. So we have on the left-hand side of the screen, we have some images showing the Part M of the second schedule of the building regulations and the associated technical guidance document. So we're all aware that Part M has been updated from previous sessions that you might have been participating in. So we're now looking at the requirements of the regulations came in on the 1st of January 2024, subject to a number of transitional arrangements. As a result, we have a new technical guidance document, M 2022. We also have some national good practice guidelines, which can, I suppose, assist in the universal design approach. So we have the NDA guidelines called Building for Everyone, which is a series of booklets around universal design, and we also have some really good national guidelines around universal design guidelines for homes in Ireland, which are being, I suppose, recommended by a number of local authorities now in relation to the design of large-scale residential schemes and apartments and so on. So there's, I suppose, just highlighting that there are regulation requirements and there are good practice requirements, and we'll be talking about both of those during the session today. So I suppose let's kick off and get straight into it and look at the first area that we'd like to talk about, which is manual versus automated doors. And I suppose just to start us off, we have a general principles of design. So doors should be suitable for all to use. There's no specifics. So I suppose one thing to watch out for is that in the guidance that's provided in TGDM, it doesn't, pardon the pun, it doesn't say that you automatically have to have automated doors or manual doors. So it's up to each designer to decide, depending on the use of the building and a number of key factors, on whether they should be putting automated doors, power assisted doors, or manual doors into the building that they're designing. But I suppose as a general rule of thumb, automated sliding doors are on a sensor are the most accessible for users, because it doesn't require someone to operate a control. It doesn't require them to pull a handle, or it doesn't so that it facilitates independent access. So some of the typical factors that you can think about if you're looking at designing your doors and trying to choose whether it's going to be manual or automated is the number of users and the building type. So if it's, for example, a large recreational building with significant levels of users, you might be going down the automatic door route. How to maximize access and use for all users, and looking at the end user requirements. So you might be designing a healthcare facility, and you might say, well, there's a lot of older people who may have dexterity issues or may have reduced mobility. So you might be looking to say, well, in this type of facility, we would be choosing automated doors as the best option, or maybe power operated and so on. So other factors that can cause issues. So for example, if you have a door that's located in a deep reveal, you may not have a leading edge on the pull side of the door. So as a result, you may need to automate your door and so on. Opening forces. So we found on a lot of projects that when we started our role as ancillary certifier, you needed to factor in the opening forces of the door. So 30 newtons or less opening force from 0 degrees of the opening cycle. So if you have larger doors, so if you had a 1 meter wide effective clear width door, which was fully glazed, it may be a heavy door, but there also is you need to factor in wind loads and different weather conditions at your building. So it became apparent from very early on that as the door gets wider and heavier, you may need to look at automating the door in that regard. Door closers, again, one thing to watch out for is making sure that you specify the right type of door closers and that they meet the relevant standards and requirements under the building regulations. And as we said, when that door gets wider, there may be an onus on automating or power assisting the doors and so on. Other considerations would be for automating sliding doors. So balancing accessibility versus safe egress out of a building. So ensuring that you've carried out significant design risk assessments in relation to, meeting your Part B and your Part M requirements in that regard. So just to look at some examples of some automated doors and just some factors to consider. So on the left hand side, you can see an automated door. It's part of a glazed facade, and the door itself is clearly defined by, the black framing of the glass. You also have, when you have automated or power assisted doors, you need to put a symbol on the doors to indicate that the door is power assisted or automated. And again, you need to make sure that your glazed manifestations are designed. So if you can see the image in the center, again, it's a revolving door with a complementary accessible door, and the framing of the glass is thicker than the actual glass facade. So that will assist people with visual impairments to navigate and find where the door is. And you can also see the access control is located, the access control point here is located away from the entrance, which means that someone can get up close to it. They can push the power assisted button, or they can use the intercom, and they can get into the building easily. And again, in the final image that we're showing here, it's inside the building, so it's internal, and the access control is located significantly back from the actual door itself, which means that if a wheelchair user, as an example, came along here and they pushed the automated controller, that they could continue on their journey and the door would be open by the time they reach it, and so on. So a good example of positioning of your access control in that example. Some additional images then again, so I suppose highlighting the importance of in the example here on the left hand side, where your framing of your doors are actually clearly defining where the actual doors are themselves. And in this example, you have well designed well designed door closures leading out onto a terrace and so on. So again, just looking at examples of door closers again. So the cam type lever is a good example of the center image of the right type of door closer to use in that regard. So the second area that we'd like to look at is excuse me, is the main entrance door design. So again, some guiding principles. So easy to find and locate. So again, remember, you have a diverse range of users coming to your buildings. They may be the first time visitor. So you want to make it easy and clear for them to find where the main entrance is, and easy to use and access. So when we provide revolving doors, so again, revolving doors are one way to design an entry, but we must provide a complementary accessible door. And I suppose one thing that we find on site is when we have a complementary accessible door, is making sure that the intercom positions are correctly located, so that they're easy to use, but also they're intuitive for people to use themselves. So don't put the intercoms right in the corner between the revolving door and the complementary door and stuff like that. But also think about this when someone's arriving, that they have enough space, so a leading edge on the pull side of the door, of the complementary door, so that someone can get up close to it and open the door and so on. So I suppose looking at when you're at early design stage, providing enough space between the revolving door and the actual complementary door would be an important one there as well. We've already discussed the door opening forces, but that's really important, that it's easy for people to open the doors and get in. But again, consider your factors like your wind loads and your weather conditions, but also the weight of the door and the type of closer but also things like maintenance of the doors as well. Barrier design and cane detection. So again, and this has been an issue on projects for a long time, but it's more and more an issue now, where some local authorities are requiring that doors should be recessed if they're opening out onto a circulation route. That the local authority wants to reduce the number of barriers or cane detection elements outside the building. So just keep an eye on that one. It's one where it may impact on your overall design at planning stage, but also at detailed design stage. So how you design your footpaths outside the doors, so that your doors are recessed out of the circulation route, is one to really watch out for. In relation to the location, I suppose located too close to the return wall, so which could impact on the effective clear widths of doors. And again, your access control, so your heights of your access control and intercoms, not suitable for both standard users. So you may, if you're designing, for example, larger apartment buildings, you may have an intercom, but you also might have some screens. So you have to be careful about the heights that you position your screens, but also your buttons, so that they can be used by both standing and seated users. And again, a really good example of universal design is think about shelter. So have a shelter or some sort of canopy over your main entrances, so that again, if someone is slow to get their keys out of their their handbag and stuff like that. That there's on a wet morning, that there's some sort of canopies in place, and so on. So again, some good and bad practice examples of the main entrance door design here. So we're looking at on the top left, we have a power assisted door. So you push the button here and the doors open. You've got cane detection, and you can see on the bottom of this image here, you have, I'll get my pen going here. On the bottom of this image here, you have a cane detection, which is less than 300 millimeters above finished floor level, which means that when someone is using a cane, they will detect the barrier and so on. And in this example, ideally that the intercom or the access control is positioned slightly back a bit here, so that someone, again, when they push the button, that the doors will be fully open by the time they reach the doors and so on. That's really important. In this example here, you've got well-designed manifestations. You've got, again, cane detection here. But as I've mentioned in the previous slide, some local authorities will now require that the doors are possibly recessed so that they don't open out directly onto a circulation route. So just keep that in the forefront of your early stage design. So again, if we look at the next set of images, you can see this is in a local school, where they have a number of doors that are opening directly out onto main entrances, and they've put lots of different barriers and I suppose hazard detection in place here in that design. So if we talk about exit doors next, so again, this is something that's I suppose an important topic. We have to get people into buildings safely, but hopefully we can get them out of build safely is equally as important. So exit doors, convenient to access and use, facilitate safe evacuation for all. So I suppose, what if we look at the guidance, various guidance documents, which I will show you in a second, whether it's regulations or whether it's standards or whether it's good practice from the National Disability Authority in Building for Everyone, they all state that accessible egress leading to assembly points. So you consider when someone gets out of the building, so they open the doors, they can get out. Then the next thing is they need to be able to get safely to an assembly point. So some design issues that come up on a regular basis as well. Do we provide level access, or do we provide stepped access outside of an exit door? If you provide stepped access, you may need to consider refuge areas and call points and stuff like that. So it's I suppose it's easier if you can provide level access or a sloped access route or a ramped access route to get people safely to the assembly points and so on. So again, in some designs recently, there have been issues with site constraints where you've had to have an external refuge area, and again, versus a place of assembly. But again, ideally, you would get people away from the building and to place of assembly. So consider risk assessments in that regard as well. Again, locks and handles on emergency exit doors should be capable of easy to operation by all building users. So again, think about people with reduced dexterity in their hand. People may have, for example, they may have only use of their elbow and stuff like that. So ensuring that the design of the exit doors addresses all of those requirements and meets all of the requirements of Part B of the building regulations. But if I just show you some information taken from an extract from TGDM. So TGDM 2022, and if we look down here at the bottom point F, it says that so all of the following entrances should be accessible. And at point F, it says building exits to assembly points are to the boundary of the site. So that's really important that it does actually state that building exits need to meet the requirements of Part M in the building regulation. So we come back to that again towards the latter half of the presentation. The next area we look at is from Building for Everyone, and I suppose Building for Everyone guidelines in relation to emergency exit doors says in the green box, aim to facilitate independent evacuation wherever possible. Consider procedures and routes for emergency evacuations at design stage. So again, some good guidance there on making sure that we consider making sure exit doors are accessible and usable for all. And then we also have an ISEN Europe, a European standard which has been adopted in Ireland, and that talks about emergency exit doors, and it makes reference to it makes reference to our national building regulations, but it also makes references to easy to use handles and stuff like that, and so on. So we have regulations, we've good practice, and we also have standards that we need to consider in relation to the design of our exit doors. Again, the next area is number 4, which is access control and intercoms. Sounds like something that's really simple to design, but there's so many things that can go wrong in relation to the design of our access controls and intercoms. We have positioning, so locating them away from corners. We have heights, so locating access control and intercoms at the right height. But then we have a lot of information. So if we have an intercom system, then we have to consider someone who has visual impairment. Is there audible announcements? Someone with a hearing impairment? Is there visual announcements and stuff like that? So it's trying to cater for as many people as possible. So we've seen some good examples around the city recently where they're fitted with hearing induction loops or hearing induction couplers, but also they visually contrast from the surroundings which they're located. So consider so we're talking about a diverse range of users. So for someone with a mobility impairment, it's the distance away from corners. It's being able to push the push pad or intercom, or sorry, the access control, so that someone can conveniently move on and get into the building. They don't have to stop and wait. But it's also things like, visual contrast of buttons, tactile, or braille on our intercoms and stuff like that. So if you look at some of the design issues that we meant, typical issues that we find, so no tactile buttons, markers, no visual contrast, no hearing enhancement system or signage. So a bit of signage to say how to use the intercom and so on. In relation to location, they can be too close to the door leaf or behind the door swing, located too close to the return wall, which means that someone in a wheelchair will need to stretch forward, and there's a fear that they might fall out of their wheelchair and so on. And then heights, not suitable for both standing, for seated and standing users. Apologies. So again, here's some images of access control. So on the left hand side we have a CGI, and again you can see you've got good visual contrast between the door and the wall. And over here then you've got an image of where the access control will be located. So positioned adjacent to the where the door is opening here. So the handle is there, so the access control is positioned here. And again, this is just an image of the access control system. So there's a light here which indicates that the access control button has been released. Here again is an older type system, but it's an intercom system with a hearing induction loop fitted. There's much more modern styles in place now. And over here we've got an image of a door release. So you don't actually have to touch this door release. You just can wave your hand in front of it. So again, it's a no-touch solution to allow you to release the door here to get through the doors and circulation routes and so on. In the next few images, then we have examples of, again, intercom. So here we've, I suppose, a poor example where we've got poor visual contrast between the actual wall itself and the intercom system. Again, it'd be very difficult for people to find the button if they had a visual impairment. And again, the instructions may be too small in that example. Over here, we have on the right-hand side, we have an intercom system which basically has instructions. The instructions themselves are in embossed lettering, and I think there's braille on that sign as well. But again, we've got good use of symbols. We've got good use of color contrast in that example as well. So number 5 is relates to door thresholds. And again, we're aware that there are, sorry, I'm just going to change the slide. So door threshold should not pose a barrier or trip hazard for users. And in Building for Everyone, the general principle of design, every accessible entrance must incorporate a level threshold, despite the challenge this presents in terms of waterproofing. Where possible, the threshold should be flush with the external ground surface and internal floor finish. So again, some design issues that we find on site is that thresholds are being installed, but the thresholds aren't chamfered or round edges. So again, anything above like 12 or even 10 millimeters, that can present a barrier or a challenge for someone in maybe in a powered wheelchair or in a manual wheelchair and stuff like that as well. Because remember, the wheels on the front of the wheelchair may be small, so they can become a possible trip issue and stuff like that. So I think it's, thresholds again, and in the height should not exceed the maximum threshold height of 15 millimeters. That's a Part M requirement. And then we also have to balance the weathering issues that you may have where you have pools of water forming if you have a level threshold and so on. So on site, there can be lots of different issues. So I'll show you an example of that in a second. But again, like the specifications are incorrect and manufacturers unaware of the Part M requirements. So again, if you are a design team member here today, and you're working with contractors or subcontractors, it's very important that awareness is key, and I suppose making them aware of some of the requirements of the regulations, but also the reason for the requirements. So if the threshold, as I said, if the threshold is above 15 millimeters or 12 millimeters, it can become a tripping hazard, but it also can become an issue for someone with rollators or walking frames or people using crutches and so on. And again, I suppose just to show here's an example of a project that we had on site recently. And again, it's quite complex. The door details on the left hand side showing you all the requirements and specifications of the door and the thresholds. And if you can see the kind of purple part there where the threshold was above the 15 millimeters, where we had to kind of slope up to a slight gently slope up into the flooring so that we could maintain a maximum threshold of 15 millimeters. And on the right hand side, you can see some images. So the top image on the right again is a poor example of a threshold which is way above the 15 millimeters, and it's not beveled or chamfered or rounded. And on the right hand side, or sorry, on the bottom image, you can see a threshold again which has got good drainage channels, and the threshold both internally and externally are less than the 15 millimeters. But also you can see there's a well-designed mat well inside the door to I suppose to look at, so for people's footing and so on. So we're going to go on, and we're just going to have a quick we're going to do a quick poll. So the details of the poll. So if I'm just going to change the slide here. So if you can log on to Slido, so www.slido.com. That's just the website to log on to in a second. And the code that you're going to insert is 1338. So 1338234. Okay. So what we're going to do is I'm just going to show you. I'm just going to give people maybe 30 seconds to log on. Okay, so hopefully everyone's logged on, and the slide, the information's on the next slide as well. So what I want you to do is take a look at the three images on the screen and identify what you think are the two most important things to improve. The two most important criteria to address to make those doors more accessible. So image 1, image 2, and image 3. So I'm going to give you 1 minute to maybe write down what you think are the most important things to get right here in relation to accessibility for the 3 doors, and then I'll launch the poll if that's okay. Okay, so I will just so hopefully everyone's got 2 things wrong with each of the photographs here. So I'll just start with image 1, and you'll be able to, on the poll, you'll be able to input your answers. Okay, so we'll just go to see what the results are. Okay, so 70% of users so far, 71%. Okay, so for image one, which was the main entrance door, we have 73% indicating door automation as one of the most important features to improve accessibility of the doors. 53% have indicated barriers or guarding outside the doors. And again, 27% have suggested glaze manifestation. So improving maybe the glazing or how confusing it may be for people with neurodiversity and so on. So graphic design or glaze manifestation. So let's move on to door number two. Door number two was the white door. So let's have we'll get into the poll here. So here's number two. So which of the following two design criteria would make this door easier to use and more accessible? Okay, so visual contrast, very good. So providing visual contrast between the door and the wall, and then well-designed vision panels is the two good answers. So there was a glazed screen at the end of the corridor, so we want to make sure that we have well-designed vision panels there, 64%. So image number three was the oak doors. Again, we'll have a look at that. Which of the following two design criteria would make these doors easier to use and more accessible? Okay, we've got effective clear width and door automation. Okay, as two as the top answers. The other one that was probably important in that one, which we didn't have, was the size of the lobby. So the size of the lobby to make sure that it is well designed to cater for people with reduced mobility. Okay, thanks very much to everyone for putting in the uh, participating in the quiz there. I'm going to continue on, if that's okay, on to number 6, which is the effective clear widths and leading edges. So I suppose, look, again, lots of projects where this can become an issue. Measuring the effective clear width needs to, in some situations, take into account things like implications of ironmongery. So my recommendation would be, when you're designing your doors at an early stage, is make sure that the doors can open beyond 90 degrees where possible, but also consider the implications of your ironmongery on them. So we you might be designing a healthcare facility with lots of little smaller meeting rooms or surgery rooms and things like that. So you need to consider the positioning of the door so that it opens beyond 90 degrees, so that you can allow for the effective clear width. The other thing to consider is the leading edges. So ensuring that you have a leading edge of minimum is 300 millimeters. But again, if we look at some of the building for everyone diagrams, which I'm about to show you, it can be up to 500 millimeters and so on. So again, some other things on the leading edge is ensuring that lobbies are designed and easy to open. And one thing to note in relation to the new regulations and changing places toilets, the effective clear width of a door into a changing places toilet is 1 meter, so 1,000 millimeters is required. So think about, does that have any implication on the corridors or the route to the changing places toilet? Should the doors be wider as a good practice initiative and so on? So again, just showing some examples of technical guidance documents. So diagram 10 is important because it indicates a number of things, including the how to measure effective clear width depending on the type of doors that you have, but also it covers things like the leading edge. So here's the leading edge of 300 millimeters on the pull side of the door. That allows the wheelchair user to get up close so that they can actually put their hand on the door handle and open the door backwards in that example there. Okay. And then there's examples of effective clear width in sliding doors where the door doesn't open fully because of handles and so on. And then just some updated information in the minimum effect table 3 of TGM 2022. Also, to recognize that building for everyone, as I just previously mentioned, it requires that you have a larger leading edge and looking at the different kind of turning spaces and space required for someone to open a door. So it's actually 600 millimeters in some of the examples there of having a leading edge on a pull side of a door. And they also require that you have a leading edge of 300 millimeters on the push side of a door, which isn't a requirement in TGM. So again, these are some of the next few images are some examples that we've come across on site. So for example, this was in an existing building that was refurbished, and it was in a protected structure. But you can see there the reveal of the wall is quite deep, so it could be 400 millimeters. But this was actually leading to an accessible WC. So a new accessible WC was located in here, but it was a manual door, and it didn't provide the leading edge of the 300 millimeters on the pull side. So again, might have been worth widening the reveal if possible, or automating the door. And again, in this image, you can't see it, but there's a sloped access route here, which is leading up to a level landing to I suppose allow people to get in the door. So making sure that you've sufficient space, that if someone's coming in this door, for example, that they, even using different color on the floor finish here would be important for someone with a vision impairment. And on the right hand side, you've a well designed corridor, so you've got good visual contrast between the floor and the walls. The door at the end of the corridor is is a different color, and it will guide people towards the end. It's got a well designed vision panel, ironmongery that contrasts. It's got access controls that are buttons light switches that are contrasting. The one thing that needs to be considered there is that the fire extinguisher should be either recessed, or there needs to be some sort of barrier there to detect it so that it's cane detected and so on. In relation to glaze manifestations, really important. So glaze manifestations can assist in in wayfinding and navigating for people with visual impairments, but also it's a form of hazard detection for people so that they don't walk into the glass. So, and again, we've all probably had the issue of walking into a patio door at home and stuff like that. So what I always say to people is, look, think about the branding of your organization. So using colors, using different logos and stuff like that. So there is a requirement that the manifestations contrast during all different lighting conditions and against the background which they're mounted on. So if you use the opaque 50 mil circles vision panels, they may not contrast in all lighting conditions. Okay, so be creative about how you actually design your manifestations. Use your color, or use the the branding of the style that you're using within the building design and so on. But again, manifestations need to be provided at two heights, between 850 and a meter, and between 1450 and 1600 millimeters and so on. And the other one that we find is that some people, if they have glazed panels, so if you have a glazed facade, so if you have an entire wall of glass, then you need to frame your glazed doors. So you need to differentiate the frame of your doors so that they contrast visually. So let's look at some examples. So again, in the examples that we have here, again, this one this image here on the left hand side may be very confusing for someone. The pattern itself may be really confusing, but you can't find out where the door is. Okay, so the door itself needs to be well defined from the space. Again, particularly for people with visual impairments, but also busy graphics and busy graphic design can impact on people with who may have challenges in relation to neurodiversity and so on. Okay. In this image, again, they've used the actual power operated doors, but they've made the manifestations a linear shape. But make sure from inside and outside the building that you can actually see the manifestations. And again, some good and bad examples in the next slide. We have here, this is an entrance to a train station, but again, the doors themselves aren't framed, so it might be difficult for passengers or visitors with vision impairments to actually pick out where the doors are and so on. So just consider framing your glass and so on, so that people can find the doors themselves. And again, this was in a recent hotel, so they used a lot of gold in the design. So they put gold manifestations and they put their own different shapes on the so that it's easy for the manifestations to stand out in various lighting conditions and so on. We've three more areas to look at. We have the door vision panels. So again, door vision panels should be provided for doors in circulation routes. And the idea of the vision panel is to stop people from getting hit by a door, but also so that people can see what's on the opposite side of the doors and so on. There are some exemptions in relation to privacy and security. So you might need, you may not want to provide vision panels into a theater where you need to control lighting and stuff like that. But you may have security concerns as well in some types of buildings. Okay. So again, the one thing to keep an eye on is the dimensions of the vision panels. So ensure the correct dimensions are provided. 200 millimeters max from the leading edge of the door. Okay, so you can't put them center in the door. They have to be 200 millimeters max from the leading edge of the door. And then if you have a side panel of glass, for example, that is wider than 450 millimeters, so you have a vision panel on the side of a door, you have to provide manifestations if it's a full height panel and it's wider than 450 millimeters. So again, let's look at some images. So we have here on the left hand side. So I always use this example as because it was designed in consultation with someone with a vision impairment. So again, you've got a well designed vision panel here. You've got good contrast between the floor and the walls and stuff. You can pick out where the door handle is, but the person didn't consider the needs of someone with mobility impairment. So I suppose I'd advocate for consultation and stakeholder engagement involving people with disabilities in your design process, but make sure that that once you do that, you're still aware of what the standards are. So the effective clear width of this door needs to be at least 800 millimeters in that example, because to allow for the wheelchair user to get through and so on. We also need to look at things like this example again, good vision panels, good visual contrast, well designed and full heights and stuff like that. As I mentioned here, the panel it's a full height panel. It's wider than 450 millimeters. So we need to provide glazed manifestations at dual heights in that example. And then you can just see some other examples there as well. The second last area that we want to cover is ironmongery. So I suppose, look, when you're designing your ironmongery, easy to grip. So again, well-designed handles. Avoid things like round doorknobs and so on, but also the positioning of the handles too close to the architrave. So you want to make sure that the handle is positioned away from the frame around the door, so that you don't knock if someone has poor strength or dexterity, that they don't knock their knuckles off the architraves and so on. Okay. The height of pull handles above floor. So there are minimum heights of pull handles that they should be above the finished floor level. So just keep an eye on that one. And then things like design of door locks. So make sure you have designed your door locks with a lever on them, so that they're easy for people to actually use. So they could use if they have a closed fist, they could use the door lock and stuff like that. Particularly in your accessible toilets or your ambulant cubicles, where you have to you have to lock the doors and stuff like that. So again, some good and bad practice examples here. So we have the wrong doorknob. So remember, that requires someone to be able to grip, twist, and apply a force. So it could be difficult to use. Again, we've a return on the door handle, which means that if you pour strength, you could still put your finger in here and pull the handle down. Again, on an ambulant disabled door, that making sure that you have the door is open outward, so that you have pull handles on the outward opening door, and then good visual contrast on the pull handles between the door and the frame of the glass and stuff like that. So again, keep an eye on that. But things like door locks, things like returns on the door handles, easy to grip, so that the profile is the diameter of the handle isn't too thick or too thin and so on. So the last area is a really important area. It's the doors and circulation routes. So again, what we have is we need to make sure that that people can easily navigate around our buildings that we're designing, and that we don't put too many restrictions with doors for people to get around. So we want to minimize the number of doors that people have to get through to get. So maybe if they come into a large office, for example, that they can get into the building, they can get into the lift, they can get up into the building, and they can get into their office areas and stuff like that. So I suppose, look, it's something that's coming up in more and more designs that we're working on at the moment. So things like holding doors open versus automating doors in corridors versus trying to remove doors in your design strategies and stuff like that. So I suppose, look, typical issues: layout, excessive number of doors on internal access routes pose barriers for people with reduced mobility or strength. So think about things like, well, in design, can you avoid having the doors in place? Can you hold them? Can you hold them open? Can you remove the doors, or can you automate them? Also, particularly if you're doing large type projects, is reducing those number of doors that people need to get through is going to be important. But then if they are held open, remember, if they close when the fire alarm goes off, you still need to be able to get people to open them and get through them and stuff like that. So it's really important that you come up with a strategy in relation to safe egress. And again, these are some examples. This is a project that we did a recent access audit on, and you can see there's a number of issues in relation to doors, opening out onto corridors and stuff like that. So again, if you look at the diagram in diagram 12 of TGDM, in the current TGDM, it says if doors are opening out onto corridors, they should be recessed, unless they're not on a fire exit route, or sorry, on an escape route. And in my opinion, if you have a door out of a toilet and you're coming out of it, then it's on an escape route because you have to escape from the building and so on. So it's important that, again, people take a look at this diagram 12 of TGDM, particularly in recessed door, where the door is not opening out onto a fire escape route. And here's another little exercise here's another little example of a building. So it's a large office building, but a number of during the opening hours of the building, the client required that the doors in circulation routes to allow people to get out of the lifts, get into the toilets, maybe get out onto their open plan desk areas, that doors are being held open and stuff like that. So coming up with a strategy around minimizing the number of doors that people need to get through and so on. And the last area that we need to look at then is just on universal design homes. So I suppose just to watch out for in relation to visitable housing versus universal design housing. So Part M requires that a house is visitable for someone with a disability, whereas good practice now relates to universal design homes, so that we design houses that can cater for everyone. More and more county development plans and city development plans will require that a percentage of houses in larger schemes need to be designed to universal design home standards. And as mentioned previously at the start of the presentation, the NDA have guidelines, and so do the Irish Realtor Association, on universal design homes. So things like thresholds, effective clear widths of doors, leading edge, door releases, doors out onto balconies. So for example, there's no guidance provided on providing level thresholds in TGDM, but it would be good practice to provide access out onto balconies, even though it's not a building regulation. And again, just to quickly highlight, I suppose, just some stuff there on universal design homes relating to doors. There's lots of really good information provided in the NDA publications, whether it's in relation to universal design homes or universal design plus guidelines. And again, you can see here, look, these are some images of buildings that we've gone into, and you can see that the thresholds are well above the 15 mil. And here another example of door clashes where doors are opening out of the toilet, but they can clash with the door handles of the other doors and so on. And again, finally, just to look at some examples of effective clear widths, higher effective clear widths in relation to universal design homes, but also in relation to leading edges on pull sides of doors if you're designing university designed apartments, unit types and so on. And then looking at things like thresholds, level thresholds. But remember, we just briefly talked there about access out onto balconies. So I'm going to stop there if that's okay, and I'm going to hand back to going along if that's okay. And hopefully I'll be able to answer any questions that you may have.